In our previous lectures of engineering drawing, in which we have taken projection of lines, we have already seen what the master solution means, what kind of data is required to start with the question, and we have also seen one example. Now, in my previous lecture, I have taken an example in which the entire line was lying in the first quadrant. Now, today I will take another example in which the line may not lie in the first quadrant. Now, I hope you already know what the quadrant system is, what kind of data is required. Now, if you are not aware of these basic concepts, please watch my previous lectures on my YouTube channel, Prof. Pankaj Lade. Now, today I will take one question where the line is not entirely in the first quadrant, or it might not lie entirely in the second, third, or the fourth quadrant. Let's see what kind of data is first of all given to us. Now, if you remember, whenever a question comes, a minimum 5 different data must be provided while solving a question on projection of lines. So let's start analyzing what kind of data is given to us. Now, if you read the question, it's telling top view of line AB. Now see, learn the language of the question. He's saying top view of line AB. That means in the data, the first thing that is given to us is the name of the line AB. So let's write line AB. He's telling top view of line AB 100 mm long, measure 70 mm. Understand carefully. He's telling top view of a line which is 100 mm long, measures 70 mm. Now you should always remember the apparent lengths. The apparent lengths, when I say apparent lengths, that means the false lengths. That means the length of the front view and the length of the top view. They can never ever be greater than the true length of the line. That means whenever the lengths are given, start comparing. The greatest one usually is the true length. Even if you don't understand what is given in the question, you can easily rectify. If the length is largest, that will become the true length of the line. So when you observe top view of a line AB 100 mm long, measures 70 mm. So top view is measuring 70 mm and true length of the line is 100 mm. So from here we can judge that the true length of the line is 100 mm and the top view of that line is 70 mm. So the first thing that is given to us is true length. So I write TL. TL stands for true length. It is 100 mm. Okay, the second data that is given to us is the front view of the line. So the top view of the line. Top view measures 70 mm. So top view, I can write TV. You should be recalling that top view is also called as plan length. So top view or plan length, I call it as PL. So TL stands for true length and PL stands for the plan length. So plan length is given to us as 70 mm. The next thing, its front view measures 85 mm. So see, front view is also given to us, the length of the front view. I hope you should be recalling that the front view is also called as the elevated length, or it can be also called as elevation. So remember, TL stands for the true length. The front view also called as an elevated length, or it is also called as elevation. It is measuring here 85 mm. I will write here 85 mm. And lastly, the top view. The top view also called as the plan length, PL. It is measuring 70 mm and the true length is given to us 100 mm. So far he has given us 3 different data. He has given us the true length, he has given us the plan length and the elevated length. So all those 3 things have been noted down. Further he is telling end A is 15 mm above HP and 25 mm in front of the VP. So 15 mm above HP, so above, put the sign. 25 mm in front of the VP, so that's in front. So above and in front, that becomes the first quadrant. So from here you can easily rectify that point A lies in the first quadrant. So the fourth data that is given to us is about point A, and just not one single data, 2 different data has been given about point A. So he's telling point A is 15 mm above HP. So 15 mm above HP and 25 mm in front of the VP. 25 mm in front of VP. So from here I could have easily recognized that point A lies in the first quadrant. Point A lies in the first quadrant. Got it? Now, the other end B is in the third quadrant. See, so that's 1, 2, 3, 4 and 5. There are two different data available in point A. And one more data has been provided to us that point B is in third quadrant. So, other end. So, that means when you talk about line AB, one of the end is point A and the other end obviously becomes point B or end B. So, he's telling that end B is in third quadrant. Is in the third quadrant. Now people, always whenever you are solving any question on projection of lines, it is mandatory to know your master solution very well. Please watch my previous lectures on master solution. First to practice the master solution very thoroughly, and I can guarantee you can definitely solve any question on lines. Now let's quickly revise how the master solution comes, because I will be needing it to solve our question. So the master solution, as usual, let's make the xy line. Let us talk about point A. I am assuming that the entire line is in first quadrant. The master solution for simplicity purpose was taken in the first quadrant. It does not mean that the master solution cannot be used in any other quadrant system. It can be used for any quadrant system. Wherever the point lies, whichever quadrant it lies, the master solution is applicable for any quadrant system. So the master solution, something looks like this. Location of point A is given to us. Let us say 10 mm above, 15 mm above, 20 mm in front and so on. So I can mark point A dash here. Let's say this is point A. Let us say theta and phi are the two inclinations of the line. Theta is the inclination with the horizontal plane and phi is the inclination with the vertical plane. So there is horizontal plane here. Let's make a line. Let's say this is the line. Call it as B1 dash. This is the true length and it is inclined to the HP by an angle of theta, let us say. Then, as soon as you mark B1 dash, you can draw a horizontal line called as locus of B dash, isn't it? Then, project this B1 dash downwards in line with point A. So, this point is called as B1. This AB1 is called as the plan length. Likewise, make angle phi here. Let us say phi is the inclination of the line to the vertical plane. Some value is given to us. This other end, obviously this is the true length. This other end is called as B2. As soon as you mark B2, immediately you can draw a horizontal line called as locus of B. Project B2 in the upward direction. Come in line with the point A dash. This point will be called as B2 dash, because it is coming from B2. This A dash B2 dash will be called as the elevated length. It's called the EL. The next thing that we should be doing is rotate the EL and the PL. So EL rotates, you get B dash, and this becomes your front view. The line A dash B dash becomes your front view. Exactly in the same line, you should be getting point B. Obviously, it is obtained by rotating A, B1, the plan length. The plan length rotates, it intersects with the locus of B. Wherever it intersects, that point is B. It will definitely be in line with B dash. So B and B dash has to definitely overlap each other. So if you join this AB, this will be called as the top view of the line. Then the distance between A dash, B dash or AB, this is called the distance between end projectors, DB, EP. So as I've already told, you need to know your master solution very thoroughly. It must be memorized, it must be learned by heart to you. So make every single effort to first know your master solution. Okay, draw as many times as you can. So that's your master solution. Now I'm going to escalate this into our question. Now in our question, observe carefully. Point A, it is in the first quadrant. Point B is in the third quadrant. Immediately if point A is in the first quadrant, so this is the first quadrant. That's a horizontal plane, that's a vertical plane. So point is there somewhere in the first quadrant. There is the first quadrant and the point is in the first quadrant. So the front view lies on the vertical plane and the top view lies on the horizontal plane. So right now I am standing on the horizontal plane. Behind me there is a vertical plane and the intersection of the horizontal plane and the vertical plane becomes an XY line. So the point is in the first quadrant. When you open the planes, XP goes down. That's why for the first quadrant, the front view will come above the XY line and the top view will come below the XY line. That's the case for the first quadrant. Now when you talk about the third quadrant, point B is in third quadrant. Now clear your concepts very properly. Point B is in third quadrant. Now if you remember, the third quadrant is shown something like this. There is a vertical plane, there is a horizontal plane. So there is a vertical plane, you are standing here, you are observing the object from here. So there is a vertical plane and then there is a horizontal plane. Always the horizontal plane will rotate in the clockwise direction. So it will rotate above. It will rotate above and we all know that the top view will always come on the horizontal plane. So horizontal plane has gone up. That means the top view has also gone up and the front view will stay below the XY line. So when you're talking about the third quadrant, the front view will definitely lie below the XY line and the top view will go above the XY line. Now, I know point A was in first quadrant, point B is in third quadrant. So since point A is in first quadrant and point B is in third quadrant, observe carefully. There is a vertical plane. There is a first quadrant here. Then there is a third quadrant here. So first quadrant and third quadrant. Line has one end in the first quadrant, one end in the third quadrant. So if I have to take the line from the first quadrant to the third quadrant, I definitely have to cross the vertical plane and go. I definitely have to cross the horizontal plane and go. Isn't it? First quadrant above HP. Third quadrant below HP. So if the line goes from the first quadrant to third quadrant, line has to intersect the horizontal plane. First quadrant in front of the VP, third quadrant behind the VP. That means definitely the line has to intersect the vertical plane also. That means when the line has one end in the first quadrant, one end in the third quadrant, the line is definitely going to intersect the horizontal plane and it will also intersect the vertical plane. So imagination is very important when you start solving any questions in engineering graphics or engineering drawing. So remember the concepts very properly. Now, as usual, I'll make the XY line. Let's make the XY line. Point A is in the first quadrant. Point A is in first quadrant. 15 mm above HP, 20 mm in front of the VP. So 15 mm above HP. So there is an HP. You are watching from the front above HP. So I will see the point 15 mm above HP. That means above the XY line. 15 mm above the HP. So I draw a very faint line which is 15 mm above the XY line and 25 mm in front of the VP. Now understand, 25 mm in front of the VP, so something is in VP, something is in front of the VP. I have to see it from the top. So if I see from the top view will fall on the horizontal plane and the horizontal plane is going to go below the XY line. So below the XY line. So I have to make 25 mm line below the XY line. So I make a 25 mm line below the XY line. Make sure that you mark the distances. So it is told it is 15 mm above HP. So I mark 15 mm here and 25 mm in front of the VP. So here is 25 mm. Let's put the projection line. This is A dash because that's the front view of point A. That's point A. Top view of point A. Now, about B, I know that the front view is going to come below the XY line because point B is in third quadrant. Since point B is in third quadrant, the front view of the line is going to come below the XY line. So B dash will be somewhere here. B dash, I don't know where, but it will be below the XY line. So locus of B dash is somewhere here. See, locus of B dash. B dash is associated with the front view of the point. So locus of B dash will be below the XY line. And locus of B, it is in the third quadrant. So that means the top view will be above the XY line. So I can write here top view of point B above the XY line and front view of not point B, okay, sorry, front view of point B below the XY line. That means locus of B dash is going to come somewhere below the XY line. I don't know where, but below the XY line. So locus of B dash, it is going to be below the XY line, and locus of B, it is going to be above the XY line. Further, what things I know? I know true length. True length is given to me. TL is given. TL is given to me. Then he is telling the plan length is 70 mm. Now observe, plan length is 8B1. The plan length is always made from point A. Now since the position of point A is precisely given to us, point A is a fixed point. It is not going to change its position in any case. So point A becomes a fixed point. So A dash and A are not going to change their positions. So it is told to us that the plan length is 70 mm. So if you observe your master solution, the plan length is made from point A and the other end of the plan length is named as B1. So A, B1. So this plan length is 70 mm. So what you do is from point A, let us draw the plan length. And it is AB1. And the length is 70 mm. So I have written 70 over there. Don't write mm. Just write 70. So plan length, which is AB1, it is 70 mm. Further, it is also told to us that the front view is 85 mm. The front view, that is the elevated length. The front view is the elevated length. It is named as A dash and B2 dash. It has to be made from A dash, and that length is 85 mm. So let's make the elevated length. Its other end is B2 dash. This is called as an elevated length and it is 85 mm. So I have written 85. A dash, B2 dash. The next thing that I know is the true length. Now observe carefully. This plan length, the other end B1 actually came from B1 dash. B1 dash is the other end of true length A dash, B1 dash. Observe carefully one more time. B1 dash and B1 are both in the same line. I have where B1 is. I know what is B1, where B1 is. Actually B1 came from B1 dash and B1 dash is the other end point of A dash. So A dash, B1 dash is the true length. Project B1 dash down to get B1. I already have B1. So from B1 you project a line in the upward direction. Project a line in the upward direction. Definitely B1 dash will be on the line of B1. So from here, from this B1, if you project in the upward direction, B1 dash is going to go. But very important, locus of B dash in our question is below the XY line. That means instead of B1 dash going in the upward direction above the XY line, it will actually come below the XY line. That means instead of going B1 dash in the above direction, will come in the below direction. So B1 goes below here. B1 goes below, and on this line, on the same line, B1 dash has to lie somewhere. Where? Right now I don't know. But I know that B1 dash is the other end point of A dash. Do I know A dash? See, I know A dash. I know the projection line of B1 dash. It is in line with B1. So I know where A dash is. I know the projection line of B1 dash, which is in line of B1. So from A dash, if I take an arc, see A dash B1 dash is a true length, and I know what is the true length. It is 100 mm. So take an arc of 100 mm, come on A dash, cut an arc of 100 mm. So that becomes the true length, which is 100 mm, and the other end is B1 dash. As soon as you get B1 dash, immediately you can tell locus of B dash. Draw horizontal line, draw a line parallel to the XY line. This will be called as locus of B dash. Observe carefully. I knew what B1 was, where B1 was. I know B1 and B1 dash are always in line. I know that B1 dash or B dash is below the XY line. So I have drawn a line, a vertical line in line with B1. So somewhere here B1 dash will come. B1 dash is the other end point of A dash. A dash B1 dash is the true length. I know what is the true length. It is 100 mm. Take an arc of 100 mm, keep on A dash, cut an arc on the line of B1 dash, you get B1 dash. Join, you get true length. If this is A dash B1 dash, if you observe the diagram A dash B1 dash, it makes an angle theta with the horizontal. So this angle that you have got is a true inclination theta. Theta is the inclination of the line with the HP. So I've got the true inclination of the line. So one of your answer has been obtained from here. Theta is obtained. And your problem at this place. One stage, the first stage of the problem is done. Let's go to the second stage now. Now come to B2 dash. If you observe B2 dash, B2 dash actually came from B2. And B2 is the other endpoint of A. And B2 is a true length. I know what is a true length. So from B2 dash, I can plot B2. Actually, B2 dash came from B2. I know where B2 dash is. If I take B2 dash and go in the downward direction, I will get B2. But in my case, B2, which lies on locus of B, for my question, the locus of B is above the XY line. That means instead of going in the downward direction for B2, I will go in the upward direction. So from B2 dash, plot a line which will go in the upward direction. Plot a line which will go in the upward direction like this. This is the projection of B2. So B2 dash and B2 are both in the same line. So B2 dash is here in the same line, B2 is going to come. So B2 is going to come on this projection line somewhere. And B2 was the other endpoint of A, B2. You know where A is. You know that A, B2 is a true length. You know the true length is 100 mm. Measure an arc of 100 mm on the rounder. Keep at point A and cut an arc which is of 100 mm length. And again you join A, B2. This angle that you will be getting, again this is your true length. True length, it is 100 mm. True length, A, B2 is your true length, it is 100 mm. This angle is going to be phi. It is angle made by the line with the vertical plane. You have got your second inclination. So you have got phi, you have got theta previously. You have got B2. As soon as you get B2, immediately draw a horizontal line which is parallel to the XY. And you call this as locus of B. Most of your work is done. Now, we know the EL rotates and goes towards locus of B dash. The PL rotates and goes towards the locus of B. So that's your PL. So PL has to rotate. It will go towards locus of B. So whatever your PL is, my diagram is not according to scale. If you make it exactly according to scale, you will definitely get a very good diagram. You will get a proper diagram, you will get proper inclinations. So this is the PL. The PL, it rotates towards the locus of B. That's your locus of B. That's your PL. So PL has to rotate towards the locus of B. So PL rotates towards the locus of B. You get point B. When you join this, AB is your top view. So PL got rotated, it came down in our master solution. Here it is going up, because of locus of B was above the XY line. So rotate PL to go and intersect the locus of B. You get point B, join A and B, that becomes your top view. Likewise, take the plan length. Take the elevated length. Plan length is done. Take the elevated length. Take the EL. And EL rotates towards locus of B dash. EL rotates towards locus of B dash. So that's your EL. It will rotate towards the locus of B dash. Locus of B dash is below the XY line. So it will rotate in the downward direction. It is a mandatory requirement that B and B dash has to come in the exact same line. They have to come in the exact same line. If they do not lie on the same projection line, that means there has been some terrible mistake in our solution. So make sure that B and B dash should come in the same line. So as I said, the elevated length is going to rotate and it will definitely pass to the same point. So this point is going to be B dash. That's B dash. And when you join A dash, B dash, that would give us the front view. So that is how the question goes. Now, I strongly recommend you, as and when you keep on watching this video, simultaneously keep pausing it and keep on drawing the solution in your drawing book as well. That is the only way you can understand how this question was made. And as I have already told lot many times, that whatever question on lines you want to solve, you definitely have to know your master solution very well. I want you to note this down very properly. Thank you so much for watching the video.